Hi folks, we're going to take a look at number 7 from the December 14th worksheet. So here what they're giving us is an equation for the force acting on a spaceship by a planet with respect to the distance away from the planet. Okay, and what they want us to do in this question, at least in the first part, is to determine a function for force with respect to time instead of with respect to distance. Okay. So hopefully what we'll be able to do is we'll be able to write distance in terms of time. In other words, what I'm looking for is a function of force which is given with respect to distance, and if we can get distance with respect to time, then that'll give us what we want. So essentially what we're working with is a composite function of f circle x at t. Okay, so this is our goal now. So what we're going to need is a formula for x at t. So we already have a formula for f in terms of x, so we've got our 1.95 times 10 to the 18 over x squared, but here we want to determine x in terms of t. Okay, so that's what we're going to try to do now. So let's see what we've got. We've got a planet, okay, and we're measuring the distance of the spaceship from the center of the planet, and that's x, and we want to find that with respect to t. And they tell us that it starts, or at least at this point, it's at 190,000 kilometers from the center of the planet and traveling at a rate of 1,200 kilometers per hour. So first thing I noticed, by the way, is that we had distance in meters here, and now we've got kilometers. So we're going to have to make sure we take that into account. But they're not giving us the rate at any particular moment of time, so I think we can assume that this rate is constant, and that means that x of t is going to be a linear function. Okay, so how do we write out a linear function? Well, it just has the form y equals mx plus b. So here the rate of change or the slope will be 1,200, but it's actually going to be negative 1,200 because the distance is decreasing over time. So we have negative 1,200 t, okay, plus b, which is our initial value. And in this case here, they give us that our initial value is 190,000. Okay? But of course, again, this is in kilometers, and we need to write this in meters. So we have to think that we're, adding another 3 zeros here, and we're adding another 3 zeros there, because obviously there's 100,000 meters in 1 kilometer. So this is where you start to really appreciate the genius of coming up with scientific notation. Okay, so let's figure out what this would be. It would be 1.2 times, so let's count 1, 2, 3, 4, 5, 6. So 1.2 times 10 to the 6. Okay, t plus here 1, 2, 3, 4, 5, 6, 7, 8. So plus 1.9 times 10 to the 8. Okay, and so now we can replace in our equation here x of t by this expression given in terms of t. So we got 1.95 times 10 to the 18 over negative 1.2 times 10 to the 6th t plus 1.9 times 10 to the 8, and all of this is squared. Okay, and this is our essentially our answer for A, because now we've managed to write f directly as a function of t. Okay, so we don't need that that middle function x anymore. So now in B, they're just asking us to determine the force at a particular time, and so what I'm going to be looking for is the force at 8 hours. Okay, so the reason why I'm writing this out is essentially what I always tell you folks, is that if you just stick something into your calculator and give me an answer and you don't specify what you're doing and you happen to make a little mistake, then I can't give you any marks for that. So you should be showing me what you're doing, at the very least writing f at 8. Okay, that's at the very least, but it would be good if you actually inputted that value of 8 into the given function that you're calculating. Okay, it's a bit of security in case you make a little mistake. Okay, so let's figure out what that is equal to. So make sure you use lots of brackets here. So let's do numerator 1.95 times 10 to the 18. Now this calculator does have a scientific notation button, but I'll just do it like this. Okay, divided by another denominator. Let's be careful here. Negative 1.2 times 10 to the 6th times our value 8, and then plus 1.9 times 10 to the 8 and that whole denominator is squared. Okay, and in the end, we've got a reasonably small number here, so we have about 60 newtons. Okay, so let's just recap this question. So number one, realize that we're given a function of f with respect to x, but we want a function of f with respect to time, so our goal was to write x in terms of time. Okay, we realized that it was going to be a linear function, so fairly easy to write out. Okay, and use what you know about linear functions, that since the value was decreasing, our slope was going to be negative. Okay, and then once you have your equation in terms of time, you were able to then solve for particular